All right, guys, in this section 11-5, we're talking about inscribed angles. So let's start with the definition of an inscribed angle. So we're talking about an inscribed angle. We are talking about an angle whose vertex is on the circle. Okay, so up to this point, we've looked at central angles. Well, in a central angle, the vertex is in the center of the circle, and remember, the central angle and the arc have the same degree measure, right? Okay. And so for the central angle, if the degree measure is 80, then the arc is 80. Okay? An inscribed angle is an angle whose vertex is on the circle, right? And an inscribed angle is half the measure of its intercepted arc. So in a central angle, it'll be the same, right? But for an inscribed angle, and again, inscribed angle, the vertex is on the circle, the inscribed angle is half of the intercepted arc. So if the arc is 80, then the inscribed angle is 40. It's always half. Now don't get it backwards. If this is 80, this is not 160. It halves to 40. So if they give you this, you double it to get the arc. You half it to get the angle. The angle is half. That's the key phrase. The angle is half of the arc. All right. So once again, and I can't stress this enough because students mess this up over and over, the central angle is the same. Central, same. Right? The inscribed angle is half. Okay. So to kind of illustrate that point, if I start here with a 30 and I double it out to 60 and then half it back down, or excuse me, and I come back to the central angle, it would be the same, which is 60. So these two are the same. This one is half. All right. So keep that in mind as we move through these problems. So the thing that we're learning that's new to this section, inscribed angle, half the measure of the arc that it goes to. How do I know it's inscribed? The vertex is on the circle instead of in the center of the circle. All right. And so there are some measures of angles here that we need to find. And so they've given me specific measurements here. All right. And I've kind of written these out here on the paper for us to look at. And so if I go ahead and plug this in, so measure of CD is 24. The measure of DE is 42. The measure of BF is going to be, let's see, BF is 102 from here to here. And BC is the same as EF. BC is the same as EF. All right, now, when you're looking at BC and EF to be the same, here's how we figured out that that was 96. Remember, all the way around the circle is 360 degrees, right? And so if I do this, if I do 360, right? If I do 360 minus 24, right? Minus 42 minus 102. Okay, so here's what I'm left with, 192. But remember, these two are the same, right? And so I'll need to divide that again by 2, and then that's how I know that each one of those is 96, because now all of these add up to 360 degrees all the way around the circle. So that's how we came up with the 96 there. So based on that, can we go through now and find each one of these angle measures? Let's see if we can. All right, so this angle 1, okay, I need to find its measure. Well, it's an inscribed angle because it's on the circle. We'll follow it out. What arc does it goes to? It goes to arc BC, right? Well, what's the measure of arc BC? 96. So remember we said the inscribed angle is half the arc. So what's half of 96? The measure of angle 1 is 48. Okay? So that's kind of how that works. What about angle 2? Angle 2 is also an inscribed angle. All right, follow it out. What arc does it go to? It goes to arc DE, which is 42. So since it's inscribed, it's going to be half of 42, 21. Measure of angle 3. Angle 3 is also inscribed. What arc does it go to? Follow it out. Trace the sides of the angle out to see what arc it goes to. It goes to arc BF, which is 102. So it's going to be half of 102, 51. The inscribed angle is always half the measure of the arc. What about angle 4, though? Angle 4 is not an inscribed angle because the vertex is not on the circle, right? It is not a central angle because the vertex is not in the center. So how are we going to find it? Well, here's where we got to think back to last semester. It is a part of a triangle in which we already have the other two angles. So remember, all three angles on the inside of a triangle add up to 180. So if I want angle 4, I'll just need to do 180 minus 21 minus 51. So if I go 180, let's see, 180 minus 21 minus 51. Oops. 51 gives me 108. Oh. All right, 108. And so now I need angle 5. Angle 5 is inscribed. What does it go to? It goes to arc DE, which is 42, and half of that, once again, is 21. And for angle 6 as an inscribed angle, it also goes to arc BF, half of which is 51. All right. So that's how we use that theorem to find all of these different angles. All right. What else do we have? Okay, so the next thing that we come to is a problem like this where it asks us to find the measure of angle 1, 2, and 3. Okay, so they've given me this arc is 2x plus 10. They've given me this arc is 3x plus 10. Okay, so based on that, I need to see if I can figure out the measure of angle 1, 2, and 3. Now, the first thing that I need to do is see if I can set up an equation that I can use to solve for x that will allow me to get these two arcs, and then I can use the fact that these are inscribed angles and half the arcs. Okay, so what about the equation I can set up here? This arc plus this arc makes half a circle, and half a circle adds up to 180 degrees. So this plus this should equal to 180. So when I write my equation, I'm going to write 2x plus 10 plus 3x plus 10 equals to 180. So there's my equation. So when I add that now, that's going to be 5x plus, let's add these two, get 20, equals to 180. Let's move the 120 to the other side and get 5x is equal to 180 minus 20. And let's also get 5x is equal to 160. I can divide it by 5. And then we'll get our x is equal to 32. Now remember, that's not the answer there, right? But that will allow me to get these arcs. So if I could do 2 times 32, that's 64 plus 10 is 74. So that arc's 74. 32 times 3 would be 96 plus 10 is 106. So now that I know the measure of those two arcs, I can get angle 1 because it's inscribed. What arc does it go to? BC. What's half of BC? Half of 106 is 53. Oops. All right, 53. And angle 2 goes to an arc that's 74. What's half of 74? 37. Okay. And for B, I see that it's inscribed, and it goes to arc AC, which is 180, and half of 180 is 90. So if the inscribed angle goes to half the circle, then it's a 90-degree angle. All right? And so that's it for this section. So there you go.